All right, Alexis B today writes, complete the square to write the function in vertex form. The height of a ball thrown from the top of a platform can be modeled by the equation f of x equals negative 16x squared plus 6x minus 34, where f of x is the height in feet, x seconds after the ball was thrown. Complete the square to write the function in vertex form. So why would we write things in vertex form? There's a number of advantages, but obviously the most important advantage is that we would actually get the function rendered in a way that we can easily see what the vertex is. So let's take a look for a second at what that looks like. Let's see, I want this open. There we go. So you can actually see what I'm looking at. All right, so here's the form of things that we are aiming for. For vertex form, we want to see things written as f of x equals, and I'm going to write it abstractly here first, some a times x minus h squared plus k. All right, and why this minus sign here? The minus sign is just to, maybe one way you can think about it more intuitively is that remembering that when we're getting bigger with x, that is when we're adding something to x, we're actually going that way. When we're subtracting something, this is supposed to be the coordinate plane, we're subtracting something from x, we're actually going to move the whole thing this way. So counterintuitively, we want a negative instead to represent the value that we get. So the vertex, for instance, being in this case hk, all right, we would want the negative to represent what we would have to subtract to x to make this 0. That in turn would give us k. If this whole thing is 0, something 0 squared times a would be 0 plus k would be k. So we would get the vertex that way. Okay, so where am I going with this? Let's see. This is vertex form. So if we were trying to use this for this problem, just making sure it's very clear, this is what we're aiming for, so that we can get that vertex if we ever wanted to. They don't ask for that, but we may do it anyway, just time granting. Now, why do we get k? It should be clear. It should be clear. If I have a problem that looks like this, that is a is positive, so it's a happy face, then the lowest part I could get, has to be when this whole thing is equal to 0. Because if you think about it, something squared, even if it's negative, is going to make it positive times another positive number. That positive number plus k is going to be bigger. It's going to be bigger. So it's just going to keep going up. And every time we plug in higher values of k, we'll be going up. Likewise, think about this if this were pointing down. Smiley face means that a is negative. So that means that k, if this is k here, this would also have to be, we would also, in order to find k, we would have to make this equal to 0 again. The whole thing, x minus h all squared, binomial squared times a, would all have to be equal to 0 to find k. And think about why, because and it's not technically negative a, we're just saying, what if a were a negative number? Some negative number, we'll just say a is negative. This is not very formal writing, but that's okay. What we're saying is that the parabola is turned upside down. Whatever value I get for x minus h squared, it's going to be multiplied to a negative number. So k, if it's minus k, for example, or whatever, k is always going to be minus something. It's going to be k minus that value, whatever that is. It's always going to keep going down the size of the parabola. So k is what we're aiming for, and to get k, we have to get this whole thing equal to 0. That's what vertex form is all about. Now let's apply this here. So we've got f of x equals this up here. And because this is already written as a function, I'm going to just get rid of the function part, the f of x part, and just make this an expression for now so that we can just play with it. We don't want to make it equal to 0. We're not looking for the roots or anything like that. We just need to use completing the square in order to rewrite it. It has to be the same values and everything. We need to rewrite it, though, in terms by completing the square in order so that it looks like this vertex form version over here. So writing it just like this, here's what we're aiming for. What I basically want to be able to do, well, first what I need to do actually, before I say anything else, notice that we need x to have nothing in front of it. which means x squared needs to have nothing in front of it. Now you may find there's another way to get to it. I find the easiest way is just to divide out the coefficient of our x squared. In other words, if I factor out negative 16, in this case, I'll get x squared plus, this will be 6x divided by negative 16. Notice that must mean the same thing. Oops, what am I writing? That must be the same thing because if I multiply negative 16, I'll get negative 16x squared, and then the negative 16s will cancel out, and I'll get 6x. Fantastic. So this is already looking a little bit more like this. But notice this says x squared plus such and such. I need to simplify this too. Let's simplify. This is ugly. Positive divided by negative makes the whole thing negative for one thing. So there's going to be in a minus form here. And then let's see. 3 goes into 6 2 times. 8 goes into 16 2 times. So they share a factor of 2. So let's just cut them in half. 3/8. And then we want to rewrite it. We just want to write this so it's nice and pretty. All times x. There we go. Now we're good to go. What are we aiming for now? We're aiming for getting this x squared to be just x minus something. And this x needs to disappear too. It basically needs to be a binomial squared, not x squared minus something x to the first degree. So to do that, we use completing the square. And here's what completing the square looks like. Basically, I'm going to rewrite the same thing. Let me actually insert it here. I'll just write it one more time. X squared minus 3/8x. I'm going to insert something. Just anything. It could be anything. I'm going to make it very specific in a moment. Minus 34. And then I'm going to be sure that I subtract the same thing at the end. And it's not going to be exactly the same thing. Technically, if we think about this, it needs to be negative 16. But let's first think about what this means. What it means is that if I'm adding something out of nothing, if I'm just willy-nilly adding something to an expression, I have to take it away again for the expression to be equal to itself, or else I'm changing it. It's a whole different problem. If I were to add 2, I'd have to subtract 2 for it to cancel out and mean the same thing as it did. Why am I adding and subtracting things though? Because remember, to make this into a binomial, I have to make this into a binomial squared. I can think like this. I know that if I have something like x squared, let's just say minus 2x plus 1. Then if I do it this way, then ahead of time, I may already know that that's x minus 1 squared. I can condense this into x minus 1 squared. If you don't believe me, you can actually work this out and see, yes, it would give me x squared minus 2x plus 1. Now, how do I do that here? This is something completely different. So how do I do that over here? I need to add something that I'm sort of making up off the fly or seeming to pull out of thin air that I can then put right back in, that I can then use to get my binomial squared, to condense it like this. There's another important aspect of this. Once I've added that, I have to subtract something of equal weight. And I'm saying of equal weight because notice all of this on the inside here is actually negative 16 times what's inside of it. So really this on the outside, I can't just subtract whatever I add here. I actually have to subtract 16 times that much. 16 times that much. Negative 16 times that much, whatever that thing is, in order for those to be equal to one another. Okay, hopefully you've seen completing the square enough times to at least know why it is that we have to make those equal to one another. Let's keep going. So what can I do? What term can I stick in there that's going to work? Let's use this other little rule for completing the square. And if you play with quadratic formula or with quadratics in general enough, you'll probably recognize why this is important or where it comes from. But basically we take some b term, or in this case kind of a quasi b term because I factored out negative 16. We're going to divide by 2, and then we're going to square it. It's that simple. It's that simple. So here, we only want to think about what's inside the parentheses to do this for now, before we apply it to the outside. So I'm asking myself, b term being negative 3/8, what is negative 3/8 divided by 2, and then squared? And I'm applying the rule. I put in my b term, my quasi b term, dividing by 2 and squaring it. Well, this is just going to be equal to, if I bring this down, keeping it in the square, if I bring this down, then I'll have negative 3/8 times 1/2. Notice that could just go up top, or it could come down like this. Multiply across, and I'll get negative 3/16 all squared. That in turn is just going to be negative, and a negative is positive. 3 squared is 9, and I happen to know that 16 squared is 256. I even double checked on a calculator earlier today when I had to work with something with 16 in it. It works out. 9/256 then is the term we want to stick in there. So let's do that here. Oh no, I'm switching to green. There we go. Negative 16x squared minus 3/8x. I am adding 9/256. 9/256. Great. And then I am subtracting 34, whatever 34. This is now a minus, so positive. So plus whatever 16 times, let's see. So this is 16 times my 9/256. 9/256. Fantastic. Which will boil down, we know 256 to 16 squared. Let's just get rid of that and go on and simplify this down to that. Fantastic. Okay, next steps. So I've got that now, and I know how to condense this because when I divided by 2, I already had the term in itself that when squared gave me 9/256. So I can rewrite this now as x is going to be minus, because I've got a negative b term there, minus 3/16 squared. And if you don't believe me, work it out, expand the binomial x squared. You'll get twice this much, so it'll have to be, it would cancel the 16 and make it an 8. And then plus 9/256, negative 3/16 squared would give us 9/256. Then, let's see, let's clean this up a little bit before we write it down here. This is now 9/16. I'll just rewrite it. So we'll say plus 9/256. And then we'll just get rid of this guy. There we go. There we go. So in order to get this to be, it's not 256 anymore. It's 16, excuse me. So now that it's 16, I need to find common denominator to add these two things together. So I'll have 16 down below, and then 16 up top. 16 times 34. I'm going to cheat a little bit and use a calculator, I think. Let's see. I will get, let me see, 34 times 16 gives us 544. Fantastic. So I get 544 minus 544 over 16. And then I'm just going to go on and combine them because they have like denominators now, plus 9. Awesome. So we can rewrite this whole thing as, and this will actually be our final form. So ultimately, we're going to get f of x equals negative 16 times x minus 3/16 squared. And then how do I need to simplify this? So 544 plus 9 is going to be, that's a negative 544, by the way. So that's going to be negative 535. Negative 535 over 16. Wow, crazy. And would not have been easy to intuit in any way, but this is it. So that means that if we were asked for the vertex, we would know instantly, given that this is minus h and we need just h, we would know that it must be minus h here is 3/16, so just h would be 3/16 for x, and negative 535 over 16 for k. That would be the vertex to our parabola, and you can plug in x and see that that works out. Hopefully you can see it already, and I hope that this helped out. So if you have this or similar questions, please feel free to contact me in the future. I'll be happy to help out in any way I possibly can. Have a good day.